Here I've got a Regency TR-1, which was the first transistor radio commercially manufactured and released to the public in 1954. This particular specimen is in nice condition. A little bit of wear at the top here, but on the whole it's in pretty good shape. Now I'll open it up and see how the inside is. These were very easy to open up. You just stuck your finger in there and usually came apart very easily. There. That's what the insides look like. It's got all its original stickers, even it's got its original plastic on the Jensen speaker. This particular one is serial number 66166, which places it in early to mid 1955 was the date of manufacture. Now this radio was interesting in that it only has 4 transistors. It was an early circuit that didn't have the push-pull output that later ones did, even in 56. Zenith, their radios that they came out with in 55, 56 actually had a push-pull output. But this radio, what's interesting is that it is the first. It used, here's the transistor, one of the transistors. We'll just look at it, it's a little blurred there. Anyway, there's a transistor. That's probably the audio output transistor. And they were all, there's another one. There's another one. They were all Texas Instrument transistors. And here is a capacitor, electrolytic. Here's another electrolytic. And those two are electrolytics too. Here are the IF transformers. Now this radio, I have already powered it up, and I hear music and it tunes. I hear music voices and it tunes, and the stations that are coming in are right on frequency. So that tells me the whole RF section and mixer is okay. Probably the problem is this dried up electrolytics. So what I'm going to do, I'd like to get this radio operational, but I'm not going to remove, since it's a museum piece and it's in perfect condition inside, I'm not going to take anything out. I'm just going to take off one side of these capacitors and put in a good one underneath, see if there's any room. I just want to get this operational. One stumbling block to getting this working again is the battery. It requires a 22 volt battery. So what I'm going to have to do to get this working is solder 2 of these batteries, which are used in some pagers. I'll have to put 2 of them together. These batteries are called A23. And it won't give a very long playing time, but it'll get it working nevertheless. In the meantime, I'm running it off. I'm just putting 15 volts on it. I'm not putting the total 22.5 volts on it. That battery that it takes is a 215. A 215 battery is very hard to get. They're very expensive. So it's not even worthwhile spending whatever amount of money to get the original battery when I could make one up. This here it says, let's see here, model TR-1 transistor radio, and it says the original batteries that it took was an Acousticon 712G, Burgess U1S, RCAV SO84, NETA 215, and Eveready 412E. So they all made it. Sonotone, General, Dry Battery, and Zenith. They all made them, mainly for hearing aids in that era. One interesting thing about this is it says that it was serviced by Regency on October the 20th, 1959, and it was warranted for 90 days. Interesting. It's interesting to note that Regency Electronics, its parent company was called IDEA and became Regency Electronics in 1961. And that company was very famous in the CB radio field. And they got taken over and sold, and there's a number of other... But the companies that came out of them still are in the land mobile radio business in one form or another. So in order to get the chassis and the inside apart, there's this little brass knurled nut here, and so you put this all the way, this here to the left, and then you just take it off like that. Very high quality brass tuning indicator, very nice. So here we have one screw connects the chassis to the cabinet, and these two are what holds in, I believe, the variable capacitors. So take this one out, and this should come apart inside. Now I'm going to take this apart again, stick my fingernail in there and separate it, and then the inside should come away quite easily, revealing a circuit board, a speaker which is in excellent condition, a variable capacitor here, which is the type they put in larger radios, and a potentiometer for the volume, and of course the on-off volume control. This circuit board is held on to the metal piece, which is this here, by little tabs, and this tab goes up into the circuit board and looks like it can be twisted out of the way, and I believe there's some up here that have to be actually unsoldered, but I will take my time doing this so nothing's damaged. So what I'm going to do here, I could even change this capacitor without, or just lift up one side and put in a modern capacitor underneath here, just sticking it so it can't be seen. And the same thing could be done with this one. This one would be more difficult, well, it would be possible. And so this one here could be changed too, without any problem. So this one is the only one that might be a bit difficult, but it is possible. So maybe I will try this without even removing these. I'll just lift up one side, keep the look, and add the capacitor, the modern one. So I put 15 volts on it, and it was very quiet, but I could hear stations in there, and the ones that were supposed to be at, for instance, 73 was right on, and it was pretty clear. So anyway, I took alligator clips and started bypassing various capacitors, and two capacitors really made the volume come on quite loud when I bypassed them with large modern capacitors. This is the electrolytic capacitors that, so two particular capacitors made it come alive. So here I'm just putting 15 volts on it, which is below what the battery voltage that would normally be on it. But here's how well it tunes.
Vancouver to Taylor Way.
Games, and remember, Caps versus FC Dallas tonight. You can listen to the match right here on 730 CKNW, starting at 6 p.m.
Here is the circuit of the Regency TR-1 transistor radio. Now it's a simple circuit, 4 transistors, but the engineer, Richard Koch, who was the designer, he had to whittle it down to make it as cheap as possible to get the best bang for their buck, considering how bad the transistors were in 1954. 1 in 5 transistors was good enough to use out of the Texas Instruments manufacturing line in those days. The circuit is very conventional, except for this particular circuit that Richard Koch developed. He developed it to make it so that they could just put in any transistors that were deemed good enough. Before that, they had to hand-pick transistors to make sure they worked properly before they could put it in a radio, and that would have made the cost prohibitive. So what he was able to do is he put in this feedback circuit. It's kind of like a neutralizing circuit in the IF section, and what it did was it stabilized this whole stage and made it so that they could put in transistors that they knew were working. Of course, Texas Instruments had already checked them, but there was a lot of instability with the transistors in those days. They would oscillate, and they had to be, each one had to be neutralized. Well, this circuit neutralized beforehand and prevented whistling and all that sort of thing. So it's a very conventional circuit. You got your ferrite rod here, your tuned circuit, your coil that couples the low impedance of the transistor to the higher impedance of the bar antenna, this is basically a step-down transformer. And here's your bias being fed from here. And this transistor receives the signal. And here's your IF oscillator. It's oscillating, and it mixes the incoming signal. And you have all your frequencies that you get when you mix two signals together, the sum, the difference, and the original frequencies. And this tuned circuit here, your IF circuit, only lets through 455 kilohertz. The transistor amplifies it, passes it on to the next IF stage, passes it on to the next IF stage, and then this third one passes it on to the detector stage. Now, in this type of radio, most of your amplification is developed in the IF section. Once you get an audio signal here, it goes through here, which is your audio control, your potentiometer, and then that is fed through this capacitor here to the audio transistor. In later designs, this would be the driver, and it would drive a push-pull pair, and then that would be matched to a matching transformer to the speaker. So here you're missing 2 push-pull transistors, which would give it more volume. And quite often in some of the higher end AM radios of the late 50s, mid to late 50s, you would have another transistor down here as a separate oscillator. But this radio works. It was not considered to be a very good radio when it came out, but it was the first, and it sold about 150,000 units, which was pretty good. Its portability. It was $45 when it was new, and that was like a few $100s today. So anyway, the radio is a classic first design, and Richard C. Koch is his name is on this is from the original U.S. patent 2892931. So the first one I'm going to replace is this 40 microfarad electrolytic capacitor. I'm going to bypass it with this 47 25 volt modern electrolytic capacitor. I always like to double check the value of my capacitors before I put them in. They could be bad, or they could be even mislabeled. So here this is close enough. It's 42.7. Here you can see I have replaced this capacitor here, but it looks like it's still there and working, and even kept the original twist. I've removed the other side, and here you can see, I'll show where I put it inside underneath the circuit board. You can probably see where I've tucked it underneath, right next to the speaker. A 47 microfarad modern capacitor, and I put sleeves on it so that it won't short out to anything. So here I've taken off the 5 microfarad 25 volt capacitor. I've just lifted one side, and I'm going to put in a new one underneath here. Here I've pulled out this coupling capacitor, and it is 2 microfarads. So in the process of replacing this capacitor here on the side, one of the lands broke, and so I realized that I'd have to separate the two upper and lower pieces here, the circuit board. As you can see there, the circuit board traces are very tiny. So in order to really do the fine work, I had to separate these, which was a bit of a bother. There's one part which is connected by solder to the actual case there. I don't know if it uses it as a ground reference in return, because after I replaced it and hooked up, after I separated them and hooked up the new capacitor, I didn't get any sound coming out of it. I didn't get any voices or music coming out of the radio, so I was a bit concerned. So I thought that I might have damaged one of the transistors, and these transistors are very difficult to get hold of, being NPN germanium. Almost all transistors, whether they were American or Japanese after the late 50s, were PNP. So these NPN germaniums are very rare. Why they originally made NPN. I guess they were the easiest to make, but then they made some breakthrough in making PNP, found them to be more stable or whatever. So anyway, so I put this on a tester to see how it was. I made this tester many years ago from, I think it was a Popular Electronics or some magazine, and it's been the best tester I've ever made or used, because it tells you, it identifies the transistor and it tells you if it's any good. If it's good, it'll just flash NPN when I press the button, and if it isn't any good, both will come on if it's a high leakage transistor. So here, I'll press the button. Whoops. What happened? So it just wasn't making contact with the little clip. So here, probably can't see it, I'll have to bring it close up. See that? There, that is showing that it's NPN and it's good. If it was leaky, the other one would be flickering slightly, but it's not. It's a good transistor, so I'm glad about that. So one thing I was wondering about when I separated these was if this, which is soldered on, is used as a return. And upon closer examination, it is used as a return. So one side of the speaker uses the metal piece as a return, maybe as a ground. So we're going to have to hook that up if we're going to fire it up again once I put the transistor back in again. Here you can see I've cleaned up this whole area, so I'm going to put the transistor, the audio transistor, back in there. Here I've removed the 40 microfarad and last capacitor, electrolytic capacitor, from the board, and I'm going to bypass this one last. There I've removed the solder from the capacitor that I showed. I removed the lead from the underside of the circuit board, and I cleaned this up with a brush. Now I'm going to put that, I'm going to put a new capacitor underneath there. So here I've got the radio all together. The only thing I have to do is to put these in, mount them with a little bit of wax underneath so that they stay in place. And all over it looks pretty good. And all I now have to do is see if it works. So this one here is the positive and the other one's the negative. So just try this. Now I'm using another power supply that supplies it with 20 volts. I can't get any more than that out of that power supply. So here, I'll plug it in. Oh, it's working. Working quite nicely. So let's tune it. Turn off the noisy light.
For $700. Spence. Located in Vancouver and Langley.
Everyone loves a good comeback. Best self.
Eternity and 3. Fabulous. For just 50. Info on the Nebraska and other autographs.
Have a chance to clinch the World Series title tonight, so we'll bring you all the excitement in the lead up to game time. Stay with us.
It's a little bit noisy here.
Officers to fight the city's extortion crisis, but some councils question whether
Yeah, so it works fine with good volume.
That's next on the Jazz Joe Walsh Show at 3.
So I put some wax on these capacitors to hold them in place. right there and here. And now I'm going to do the final assembly. So here we are. Twist this back and put the tuning indicator on. Nice and tight. There we are. Here's what the radio looks like without its back on. All looks like it did when I first opened it up. The capacitors that are replaced are all in place, and now I'll just fire it up for one final time before I put it back together completely.
When you let chances like that
Here the radio is all working.
We recognize they have made some effort, but it's not good enough.
Since the Yankees did it. So there's a lot of history at play here. Game 7, they are the greatest. It is
A candidate for the follicular unit extraction technique. The results speak for themselves. Check them out online and find out why patients from all over the world come to Hassel.
Working really good.
for their hair rest.
There's one thing I forgot was this little membrane here. It fits around the speaker. There, we've got that back in, and now it looks about as original as it can be.